So hi everyone, we are now looking at finding the inverse of a matrix, and for you to find the inverse of a matrix you must be able to know how to determine the determinant of a matrix. So we shall begin with finding the determinant of a given matrix. So the first question we have been given there is find the determinant of matrix A, which is given by this. So the procedure solution. For you to determine the determinant of a matrix, the first procedure, the procedure is Roman number 1. You need to get product of right hand diagonal elements. Product of right-hand diagonal elements. The right-hand diagonal elements are these. That is the right hand. This is the right hand diagonal. And this is the left hand. That is the left hand. So product of the right hand diagonal elements, that is the first procedure. Roman number 2, product of left hand diagonal elements. Product of the right hand diagonal elements, meaning here i.e. 4 times 5. Product of the left hand diagonal elements, which is 3 times 8. The third procedure, subtract left hand from, or simply we can say subtract step 2 from step 1. So basically determinant which is denoted by DET, determinant of A. It is written as, in short, DET. Determinant of A will be given by the right hand diagonal, which is 4 times 5, minus, into brackets, 3 times 8. That is why I said step 2 from step 1. So this is the same as 20 minus 24, so the determinant is minus 4. So that is how you get the determinant of a given matrix. We have shown how you can be able to determine that particular determinant of a matrix. We now want to move into example 2, where we will show how to find the determinant. But basically what I've said is, for you to get the determinant, you take the right hand diagonal minus the left hand. Right hand diagonal minus the left hand. So basically that is the shortcut of being able to get the determinant. We now move to the inverse. Example 2. Example 2. Find the inverse of this matrix. Find the inverse of a matrix. Find the inverse of a matrix A, which is given as 48, 35. This basically means you need to undergo a number of procedures, as I'm going to list them here. Solution. Number 1, you need to find the determinant. Find the determinant. That we have already found. Find the determinant, that is the procedure number 1. Procedure number 2. Interchange the elements. Interchange the elements of the right hand diagonals. Interchange the elements of the right hand diagonals. We are saying you interchange the positions of the right hand diagonals. You switch them. Number 3, change the sign of the elements in the left hand diagonal. The left hand diagonal. So meaning if an element in the left hand diagonal has a minus, it becomes a positive. If it is a positive, it becomes a negative. That is basically what we mean by interchanging the signs. So I've said in the right hand diagonal, you will interchange. You will switch them. What is up comes down. And in the left hand diagonal, you change their signs. So I want us to, after that, number 4, procedure number 4. After you have executed procedure number 2, procedure number 3, you will now rearrange this particular matrix and multiply. So the resulting matrix from step 2 and step 3 i.e. what is the resulting matrix after you execute this and this? We have said you interchange this and this, meaning 5 will go up, 4 comes down. 5, 4 comes down. Have interchanged. These are positives. I change them to negatives. -3, -8. So I have executed step 2 and step 3. So the resulting matrix is this. So the resulting matrix from step 2 and step 3, i.e. this, is then multiplied by the reciprocal of the determinant found in step 1. So after we have done this, we can now move to that step. And remember, the inverse is written in this form. The inverse is written as this. Sometimes you can find, if they write a power -1, it means that is the inverse. So the inverse of a will be given by, I've said, you will take the reciprocal. Remember, find the determinant, i.e. we have said before that, how do you get the determinant? Remember, the determinant here was found by, taking 4 times 5 minus 3 times 8, and remember this was -4. So when we say you are taking the reciprocal of this particular determinant, it means you are taking 1 over. So we will be having 1 over -4. We have taken the reciprocal of the determinant. Reciprocal of the determinant means take 1 over that particular number. And then we shall multiply by this particular matrix, which is 5 minus 8 minus 3. We have 4 there. So basically, what we have done, multiplied by the reciprocal of the determinant found in step 1. That is basically what we are doing. After you do this, you will realize that you will be having, this times this, you will get it 5 over 4, which is minus. Then if you will be having this is -8 over -4. This one is -3 over minus 4. This is 4 over minus 4. Remember, this becomes minus 5 over 4. That is 2. This is 3 over 4. And that is minus 1. So therefore, the inverse of that matrix, becomes minus 5 over 4 to 3/4 over that. So that is the inverse of this particular matrix. One thing I would want to state, if you are told to find, so that is the answer. Just general, a general statement. If you are told to find 4, 8, 3, 5, and they put straight bars. These straight bars means you are supposed to get the inverse, the determinant, sorry. The straight bars means you get the determinant. So the straight bar, always, whenever you see the straight bars, they mean find the determinant of that matrix. So do not confuse. If you wanted to write this, is different from somebody who will write this. This means this is just a matrix. This means you having a matrix, but the straight bars commands you to find the determinant of this matrix. So the straight bar means find the determinant of that matrix. So this brings us again to the end of this particular session. Thank you.